Hypothalamus artificial intelligence, HI. Digital transformation powered by real-time, intelligent, and autonomous algorithms. Presents its solution based on decision-making artificial intelligence to select the marketing strategy, demand-driven, or driving demand, or demand chain optimization through scientific marketing. A company's value chain is made up of two chains, which are strongly interrelated. Demand chain determines all the processes that are carried out to attract customers in the markets, and supply chain determines all the processes that are carried out to produce the products that customers want to consume. From the point of view of organizational management, it can be said that the demand model and the production and sales model are the hypothalamus of the organization. How these two models are handled is the cornerstone of successful planning. A very good demand forecast, followed by regular production planning, or a regular demand forecast followed by very good production planning, will put the organization at risk. The modeling effort must be done in both directions. The question is: marketing strategy, demand-driven or driving demand? Demand-driven? The term was invented in 2002 at PeopleSoft. It was and is still defined as sensing changing customer demand, then adapting planning and production, while pulling from suppliers, all in real time. Under this approach, the organization's demand planning is done by the market, which determines what the organization should produce. Driving demand. The term is used by HI to name its approach to integrated supply and demand chain planning. It can be defined as demand controlled by the seller, or by the producer, who decides from the potential demand which one should be attended, and how it should be met. Under this approach, the organization's demand planning is carried out by the organization, deciding what to offer to the market, taking its potential demand as a reference, but deciding autonomously and optimally what demand it wants to meet. Market demand modeling. Roadmap for advanced analytics. The first step in the demand forecasting process is to select the databases that will be used in the process. Three types of databases are available. Those of the company itself. Syndicated databases, which are provided by third parties, whose function is to measure market behavior. An example is Nielsen database, which analyzes the market for mass products, and other databases, which provide information on exogenous variables to the company, but which affect the market. For example, climate-related databases. In the future process, we must consider collecting data from new entities entering the market, for example, new customers, areas, products, and others. After the selection of the databases, the data must be cleaned, which can be done by means of artificial intelligence tools, such as DEA, data envelopment analysis, or similar. It can be said that forecasting models are born with multivariate linear regression models. However, the proliferation of artificial intelligence methodologies based on artificial neural networks, machine learning and advanced probabilistic modeling, has led to the process being more complex, but much more effective. The goal is to have the best segmentation in the market, and the best models for that market. The results of the demand forecasting model, DEM, serve as input for other mathematical models that support decisions in multiple functional areas of the organization, whether they are demand chain management or supply chain management. The central idea is to manage demand, to capture most of the social surplus. This is having a company that handles the demand, rather than a market demand that drives the company. Given a set of new entities, samples, each is classified into a segment using the mathematical rules identified in the segmentation process. The process of classifying entities in segments, known or unknown, consists of three steps: cluster analysis, definition of the groups, clusters, categories, segments, etc., into which entities can be grouped; segmentation, models that determine the mathematical rules that each entity, or sample, must meet to be part of a segment; classification, processes, or models, for classifying new entities into already defined groups/segments. These methodologies are part of machine learning methodologies. Forecasting models produce a great deal of information, but to capitalize on that information, they are required to feed optimization models that produce decisions. Their most widespread use is that they serve as input to the following models: SandOp, sales and production planning, and definition of inventory policies. As a complement, there are the models for operations scheduling. Revenue management, also known as price optimization, determines the dynamic pricing policies of products throughout their life cycle and temporal seasonality. Customer management, artificial intelligence models aimed at determining the behavior of groups of customers or specific people. Product portfolio management, aimed at supporting the sales efforts of salespeople at times when they must serve customers, and campaign optimization, optimization of product promotion activities, can be considered as part of the marketing mix models. Demand modeling. Forecasting aggregate demand in a sector, area, manufacturer, category, and/or channel, or combinations of the above, has two alternatives. Bottom up. The projection of aggregate demand is made at the lowest level of the grouping, at the level of the atom, which implies having the capacity, data and computing power, to estimate a statistical model for each demand series, product, point of sale, POS. Atoms relate to SKUs at a point of sale for a day. Top down. The projection is made at the level of aggregate demand, and then it is disaggregated at the level of atoms, for which it is required to have disaggregation rules, which are generally not self-evident, and therefore they are rules of thumb. If possible, High prefers the bottom-up method. From the point of view of the volatility of the data series, and therefore of the projections, volatility is expected to decrease at the aggregate level. However, the above is true if the demand correlation in atoms tend to have neutral or negative correlations. If the correlation is positive, the volatility of aggregate demand will be higher. The first step in structuring a demand model is to select the type of statistical model to use. The first models available were self-explanatory models based on time series of the Box and Jenkins type. The current models are exogenous models combined with self-explanatory models, based on the theories of Box and Jenkins, complemented by Garch models, and including exogenous variables. The generalized autoregressive conditional heteroscedasticity, Garch, model, is a statistical technique used to analyze time series data, if the variance of the error term, or the difference between the actual and predicted values, is serial autocorrelated. The demand for products, and/or services, is the result of the integrated impact of multiple factors. These can be grouped into economikos. Prices, product and point of sale attributes, competitor activities, advertising, and seasonality of multiple kinds. This implies that a demand model that only considers consumption time series, and possibly sales prices, leaves out important effects that affect demand. For this reason, models based on simple time series, such as Box and Jenkins, need to be expanded to consider all the effects. The two main results of the DEM model are characterization of the competition, and characterization of the client. This is summarized in algebraic equations, which characterize the mean and the variance of the demand process, so that the characterization is probabilistic. To estimate all the impacts, more specifically the elasticities of demand with respect to the factors, it is necessary to add databases from different sources to the company's databases, depending on the type of market. As an example, the image presents information from the following types of databases: historical sales information, hydroclimatic databases, socio-demographic information, Nielsen, syndicated database, history of promotions, own and competitors, and seasonal events. Effects included. The model must allow the inclusion of different types of elements, to represent processes of demand for goods and/or services with very different behaviors. In DEM, the generic equation to explain the average demand is made up of the following additive components. Elasticity of demand versus price. Cannibalization. Pantry loading. Lost sales. Time trend. Periodic seasonalities. Seasonalities of events, or business initiatives. Effects of global exogenous variables. Effects of regional exogenous variables. Autoregressive effects. Moving average effects. Product attribute effects. POS attribute effects, and zone attribute effects. With proper modeling, it is possible to decompose demand as the sum of the impact of the different factors. This applies to every product, every point of sale, and every period. For example, the demand may be broken down into base demand, competitor pricing and promotions policies, product features, seasonality, and company marketing policies. The elasticities of factors, which are under the control of the company, are essential to optimize the marketing mix and market share, and others marketing and sales decisions of the company. This implies that the process of sampling events, and in general the collection of information, must consider the activities that are planned to be carried out in the future. Therefore, the demand model aims to answer the main questions about market behavior. High-Dem provides quantitative answers to questions such as: what is the immediate effect of marketing mix decisions, e.g., 2-for-1 promotions, space events, advertising investment, etc.? What is the impact of periodic events on demand, e.g., end of month, fortnight, Easter, day of the week, etc.? What is the impact of promotions in later periods? What is the effect of product features, e.g., colors, textures, etc.? What is the effect of point of sale features, e.g., size of the premises, floor, etc.? What is the natural level of growth in demand, without considering seasonality, or marketing events? What is the impact of exogenous variables, such as climate, national GDP, or regional GDP, or population? What is the demand-price elasticity of each reference? And does this elasticity behave seasonally? It is a question of individualizing demand in all its components. Then, the process begins with a demand model, capable of decomposing demand into multiple effects. And in a next step, produce the demand projection, to be used in an optimization model that produces the decision about marketing and sales. In this case, the optimization of the marketing mix allows us to define the optimal mix of expenses in different advertising media, using different channels to reach the public. The model determines, as more advertising is spent, the elasticity of demand with respect to advertising, the slope of the blue curve, decreases. The maximum win point, 5, does not coincide with the highest spend point. This is due to the elasticity of demand. Distribute costs optimally between the different media. These decisions are not intuitive. Planning driving demand or planning that drives demand. Demand controlled by the seller who decides the optimal demand to be met and how to do it. It corresponds to a proactive position of the seller in which, based on artificial intelligence models, the seller tries to influence buyers to make their purchases in response to the seller's actions. Some examples: targeted offers at the time of accessing a website, selection of the days on which the beer festivals will be held, determination of campaigns in the advertising media, choice of marketing campaigns according to the points of sale, and definition of prices according to the points of sale, the times of the day, and/or the events that occur, among many. The flow of the analytical process is data cleansing, prediction model, forecasting, selection of control variables, and optimization model. Control variables are decisions that have been defined, in the past, by the salesperson. For decision makers, a demand model with only uncontrolled variables is only informative, as the seller will not be able to manage the demand. An example of an uncontrolled variable, weather, and a controlled variable, promotions. In a traditional approach, The control variables are defined by the decision makers, based on their mental model, and therefore, directly or indirectly, are input data to the optimization model. In a traditional approach, the control variables are defined by the decision makers, based on their mental model, and therefore, directly or indirectly, are input data to the optimization model. The graph presents a projection obtained with the DEM model for a product at a point of sale. The demand series has been broken down into uncontrolled demand, time trend, plus 1.6 kilos per month, monthly average, in the second row of results, reference month December, and seasonalities, week, only present in the year 2011 to 2012, controlled demand, promo 1, less 11.45 kilos per person, and promo 2, plus 6.24 kilos per person. The control variables are the two promotions, 1 and 2, which indicate to the company that promo 1 decreases demand, relative to promo 2. If there are multiple points of sale, with different impacts, and a single promotion to be made, an optimization model could perform the calculations to select which is the best decision. Below is an example of synchronizing models to plan for access to new markets. The process begins with a demand model, capable of decomposing demand into multiple effects. In the case of new markets, there is no adequate information in the seller's databases. An alternative is to use a syndicated database to provide the information. For demand forecasting, the simplest and riskiest position is to assume that the environment scenario will be equal to the average values of demand, generated from the average values of the parameters, and the exogenous variables of the statistical models. This involves the input of a deterministic optimization model. A better optimization model consists of generating multiple scenarios of the environment, using a Monte Carlo simulation to generate synthetic scenarios, which will be processed by a stochastic optimization model, which takes the random scenarios as input. A better optimization model consists of generating multiple scenarios of the environment, using a Monte Carlo simulation to generate synthetic scenarios, which will be processed by a stochastic optimization model, which takes the random scenarios as input. If modeled in such a way that the optimization model determines the control variables, the input demand to that model will be reduced to the basic demand. In short, there are two steps to demand forecasting, the natural one, and the company-controlled one. In planning for access to new markets, the second big step will be to use a model to characterize the behavior of market share, and from there create a profile of the type of competitor that would be the seller in a new market, or the profile in a market in which it is already participating. A traditional model involves using the forecasting models in the first stage, generating standard projections, and these projections are used as input for an optimization model. Considered as a process, market share determination is the result of three stages: demand study, optimizing the marketing mix, and market share projection through an optimization model. The third step will be to use a production model to determine how the current supply chain, or an extended chain, would work, taking into account the new market. In this way, the three models together will support the decisions. Ideally, you want to combine the decision steps into a single model for maximum expected returns. The power of today's computers makes it possible to integrate mathematical models of all functions as an integrated problem of the entire organization, which should not be faced in isolation. To do this, it can be visualized that the result of predictive models are algebraic equations, which are usually converted into input tables to optimization models. The integration of the models can be carried out by including the algebraic equations of the predictive analytics models in the optimization model, in such a way that a single predictive prescriptive model is available. This implies that controlled demand scenarios are not exogenous but are generated by the model from the activation of the control variables. Although this model requires more computing power, in return it produces better solutions. In economic terms, this is a higher profitability. Using this methodology, prediction models can be linked to any optimization model. Following the methodological principles of artificial hypothalamus, a network of demand models can be built, which can operate autonomously, and in a distributed way, according to the administrative functions they support. This is a new way of looking at the same problem, but modernized to take advantage of Industry 4.0 technologies. Artificial brains, and more specifically the artificial hypothalamus, make it possible to integrate all models, in the same way that the human brain, simultaneously faces all problems to ensure its existence and well-being. Products and experiences. For those interested in learning more about the capabilities of high models to forecast demand for massive consumer products, we invite you to watch the video. Demand prediction of FMCG products. Below are some of the experiences that HI has capitalized on. Market share modeling. Challenge: to design a methodology for the evaluation of the food market potential in Colombia and other potential markets, to optimize the strategic decisions about the marketing global expansion of the company. Solution: design and implementation of 2 statistical models, I, bottom-up demand, and 2, market share. An optimization model developed oriented to define the marketing mix decisions related to market share. Result: using the syndicated Nielsen database, the results are used to make strategic decisions on the expansion of its food demand and supply chain. Demand and price forecasting. Challenge: to implement a solution to manage the inventories of a bookstore chain. Solution: design and implementation a set of advanced analytics which involves the I, characterization of the demand for the final products, 2, determination of optimal minimum inventory levels, and 3, inventory balancing among the distribution centers and the shops. Result: the models were delivered to an integrator company. Salesman portfolio optimization. Challenge: to implement informatic tools to support and optimize the sales operations. Solution: design and implementation of a DSS for management of salesman portfolio. The models include the integration of data mining, machine learning, methodologies with mathematical programming optimization models. Result: the solution optimizes the supply of products to the traditional channel and sales force portfolio assignments. It was implemented linked to SAP ERP to operate daily, solving more than 128,000 optimization problems each day. Challenge: to develop a mathematical model of the technical economic impact of the service model, a dynamic combination of sales resources, promoter, market developer, pre-seller, promoter, shelf racks, telecalls, internet, fridges, free samples, financing, that organizations use to develop the market via several distribution channels, traditional shops, specialized schools, gyms, eating and drinking, self-service modern channel, street vendors, home. Solution: design and implementation of a mathematical model of the impact of the services model that manifests itself in various ways and changes depending on the moment in which a certain service strategy was started. Service strategies correspond to typical combinations of resources. The model solves the question: what is the combination of services strategies to distribution channels that must be applied at a certain time, over a certain period to achieve a certain objective? Result: the model was delivered to an American consulting firm, which provided professional services for a Coca-Cola distributor. Alfred North Whitehead affirmed, "Algebra is the intellectual instrument which has been created for rendering clear the quantitative aspects of the world."